All right, here's a blast from the past, solving quad systems. Again, to solve quad systems, if they're both equal to y, we can equal them to each other, which they are. So that means x squared plus 2x plus 5 is equal to negative 2x squared minus 4x plus 2. You then, since it's quadratic, got to get everything to one side. So I have to add 2x squared, add 4x, subtract 2 from both sides. To get 0. So that would give me 3x squared plus 6x plus 3 equals 0. I then realize and recognize that 3 is a common factor in all terms. So since I'm solving an equation, it's okay to divide everything by 3 to make my numbers smaller and easier to manage. And by doing so, I would have x squared plus 2x plus 1 is equal to 0. Now I'm going to factor to solve the rest of this. When I factor, a times c, which is 1 at the top, b at the bottom, and the only factors of positive 1 that would give me a positive 2 are 1 and 1. So that means my factors would be x plus 1 with x plus 1. So we got to, since they're the same factors, we would only take 1 out of the parentheses, equal it to 0, solve for x, and x is going to be negative 1. Now that I know what x is, I need to replace x into either of the equations from above to find the y value. I'm going to go with the one on the left. Y is equal to x squared plus 2x plus 5 because it has smaller numbers. But again, either one, it doesn't matter. So I'm putting in negative 1 for every x, and now let's begin our order of operations, which says to square negative 1 first, and you're going to get a positive 1. Then positive 2 times negative 1 is going to give me a negative 2. So then 1 minus 2 is negative 1. Negative 1 plus 5 is 4. So the solution to the system is negative 1, 4. Again, a system has to have an x and a y, and it has to be written as an ordered pair. We also talked about inequalities last, about 3-4 weeks ago in the last unit. The first thing we have to do to solve this inequality is find our roots, but we can't find our roots until everything's on one side. So that means subtract 3 from both sides, which gives you 2x squared plus 5x minus 3 is less than or equal to 0. I now will factor this problem as well because, again, I can factor much faster than using the quadratic formula. And if I factor, again, you put a times c at the top. This is to help me split the middle. A times c is negative 6. B is 5. And to get negative 6 but a positive 5, I need a positive 6 and a negative 1. So to split the middle, it would look like 2x squared plus 6x minus 1x minus 3. Put that in a box. So 2x squared plus 6x minus 1x minus 3. Now find the GCF of each row. For the top row, it's 2x. Then 2x times x is 2x squared. 2x times positive 3 is positive 6x. X times negative 1 is negative 1x. And negative 1 times positive 3 is negative 3. So now I know that my factors are 2x minus 1 with x plus 3. I still have to set them equal to 0 to find the x values or the roots. So on the first root, it's going to give me x is equal to positive 1 over 2. On the second one, x is going to equal negative 3. Now that I know my roots, since there's only one variable, and that's x, I'm going to use a number line. Again, there's only one variable, which is x, so we use the number line. So I got negative 3 first, and then 1/2. And then pick a test point. I'm going to use 0, which is between. You don't have to pick a number between, but sometimes it's easier to do it that way. And use the test point in the original problem. So that's 2 times 0 squared plus 5 times 0 has to be less than or equal to 3. Again, I'm using it with the original problem. So on the left-hand side, it computates to just be 0. 0 less than or equal to 3? Yes, that's true. So notice that 0 is in between, so that means we're going to shade in between. We need closed dots on our roots because there's an equal bar. And then connect the dots, please. No arrows. There's no arrows when it's in between. Just simply draw a bar that connects the dots and make it very clear as to what is where the shading is. And then write the solution in the following manner. Negative 3 less than or equal to x less than or equal to 1/2. So the graph is not necessary as far as your grade is concerned, but it is useful to you to make sure you write the solution correctly. Number 13 wants us to simplify this, so let's expand the parentheses first. Since it's squaring, that means we need 2. And now apply the box method or the double distribution. I'm going to go with double distribution because either you know how to do one or the other by now. We've done it so many times. So I don't need to demonstrate the box anymore. If you like the box and you're comfortable with the box, please, by all means, use it. Miss Perry just doesn't want to use it anymore. So 7 times 7 is 49. 7 times negative 2 is negative 14k. Negative 2k times positive 7 is negative 14k. Negative 2k times negative 2k is a positive 4k squared. Combine your like terms, that's 49 minus 28k plus 4k squared. And then put it in the correct order. So correct order would be 4k squared minus 28k plus 49. Number 14 is another question where we have to simplify. So the first thing we need to do is distribute 2a into the first parentheses. So that's 2a times 5a squared, which is 10a cubed. 2a times negative 9 is negative 18a. Then I see a subtraction sign in between before the next parentheses, so distribute that as well. So that's going to be a negative 3, a positive 8a cubed, and a negative 4a. And then bring down plus 7. Nothing happened with it, so just bring it all the way down for now. And now combine like terms properly. So I have 10a cubed, 8a cubed, so I have 18a cubed. I have also negative 18a, negative 4a, so I have negative 22a. And lastly, I have negative 3 plus 7, so that's plus 4. If you're careful, you should not miss that question either on the test. You can handle that. I believe you can. Now, we gotta simplify with exponents. So the first thing I'm going to do is take care of the like bases that are within my parentheses before I apply my power. So there are no other numbers, so 4 is going to come straight down. But then I'm going to put the like bases side by side. So I have x to the 1/2 times x to the 2/3 times x to the negative 9/2. And then I have times y to the 2/5 times y to the negative 8/15 and also times y to the 7/2. So again, all I did was rearrange and put the like bases side by side. So I know at the end of the day, I'm going to have x and I'm going to have y. I just need to figure out the powers. And again, when you're multiplying bases, powers add. So I need to take 1/2 plus 2/3 plus negative 9/2. And that result will come on top of my x. And then I'm going to do a similar thing with 2/5 plus negative 8/15 plus 7/2 and take that and put it on top of my y value. So if you don't want to do the fraction work by hand, again, by all means, consult the calculator. So alpha y equals 1. First one is 1/2 plus 2/3 plus negative 9/2. So negative 10/3 is going to be the exponent for x. Alrighty, let's drop this down since I already know I got 3 fractions. The first one is 2/5. The second one is negative 8/15. And the third one is 7/2. All right. So for y, it's 101/30. Yuck, yuck, and yuck. But whatever. So again, negative 10/3 and 101/30. Okay. Negative 10/3 for x and 101/30 for y. Again, all of that is still inside the parentheses, so let me write it a little better. 101 over 30. Again, all that is still inside the parentheses, and there's still a power of 2 attached to the parentheses. We now will take that power of 2 and distribute it to the powers. So we're going to multiply it with the powers that are existing. So when I multiply it, I will have 4 squared x to the negative 20 over 3 and y to the 202 over 30. If you can reduce, reduce. If you cannot, don't worry about it. 4 squared is 16. I can handle that. Negative 20 over 3 doesn't reduce, so it stays as x is negative 20 over 3. However, y can reduce. 202 over 30, they're both even, so you can divide them both by 2. And when you divide them both by 2, you're going to get what we had in the first place, which was 101. I'm sorry, no, we didn't have that in the first place. It's 101 over 15. And I don't believe that goes any further, but we could always consult the calculator to double check. So alpha y equals 1. So 202 over 30. Yeah, 101/15. That's what I thought. So we are done. Yuck, but that's the rules. You can handle it. Let's take another break.